Bismillah, Assalamualaikum warahmatullahi wabarakatuh. Hello guys, welcome back to this video. And in video we will continue our material in previous video. And yeah, in previous video I show you guys about EIGRP Summarization Material and Unicast Update Material, right? And in this video, I will show you guys about EIGRP default root summary address, and maybe I will show you guys how to redistribute EIGRP to RIP too. Okay, so yeah, I will use last topology. And in here, so before I continue, maybe I will. I will explain you guys about this plan first before we go to the practice. And okay, so AJP default root summary address. So what is this? So this is where we want to summary network or an IP in routing table, and when we summary it, it will be a default root. Okay, so look at this. So we know IP summary address AJP10 like we do in our lab before. I will show this. So in here we know that we make a summarization that combining five different IP address to be a one network with a bigger prefix. But um, yes, in this lab, the the after we execute the configuration, the summarization will show like this 3330. But yeah, because in this configuration we only summarize some of IP address in the routing table. But in this lab, AJP default to summary address, we want to summary all of the IP, all of the network that router tree has to be a default route 000 with the subnet 00. So it will be summary all of IP address in that router tree have. And when we see in the routing table, it will show the flag D, it mean AJP, and the star here it means default route. So 0.0.0.0 slash 0 is a summary from router tree. Okay, so let's make second configuration. So show, okay, so and configuration should run. We see that in here we still have IP summary HTTP10 here. So I will router AJP and delete it. So no IP summary address. IP summary is AJP. Oh no, it's the interface. Interface Ethernet 0.0, no IP summary address, AGF10 3330 slash 4. Okay, enter it, and now we make the configuration of the IP summary address AGF10 0. So same, but the IP address would be different. Only that matters. HFS 0.0, IP summary address, EIGRP 10 0. So it will have same configuration as the summarization before in lab 8. And yeah, when we see to show IP root in router 1, you can see that these there is an IP address, default IP address 000/0 in router 1, and when we see in show IP root, you can see that we have the same, and here we show IP root, and he has the same. Yeah, yeah, we can see that in the router one that he didn't have a network from router 3, but he have specialty a different route that um, drag him to router 3 uh, um, to ping, yeah, no, uh, show IP route 333 to show IP route 333. To show IP route 3333. Boom. Network is not in the table, right? Because yeah, this router one didn't have the network 3.3.3.3 from router one, but he have a network default. So when we want to do a ping 3333, it will success because he didn't have the network 3333 in his routing table, but he have the default route of router 3. So he's still camping, but he didn't have the network in his uh, routing table, like that. That's simple configuration for default summary address. Because yeah, that's the same configuration, right? Okay, maybe now we will continue to our next material in this video is about how we redistribute RIP dynamic protocols, dynamic routing protocols to EIGRP dynamic protocols. So in here in router 1, we make RIP specific 1 IP address 100 slash 32 router RIP version 2 network this IP network what the router ID of router 1, now the summary as, and after that we router AJP redistribute IP. So you can see here that we only redistribute air IP hexa redistribute. And in router T, when we want to show IP route AJP, we there's now the network of ARIP routing protocols. Why? Because so as we know that dynamic routing protocol has something that called metric. So what the function of metric in dynamic protocols? So metric is some calculation that dynamic routing protocols do to make sure which one is the faster way, which one is the main way to go to destination. And because AGRP, the metric of AGRP is a hybrid, and the metric of the magic of EIGRP is hybrid, or we can say that he will calculate a key value, and RIP have a different metric. RIP has a different metric of distance factor. So with these differences, well, when we only type redistribute RIP and not tell the EIGRP about the metric of RIP, EIGRP will confuse because they have a different metrics, right? So it won't um, it will not appear in EIGRP table routing. So what will do is we will so as we say before that AGRP metric is a key value. So key value is have a 5 different variable in key value. So we have a bandwidth, delay, reliability, load, and MTU. So bandwidth, delay is a delay, reliability is like how much we trust the way, load is a load of the package. MTU is like so basically MTU is like more bigger the variable is will make the yeah road is will bigger. Okay, that's the explanation. I'm sorry for the explanation. Yeah, you can search what the MTU is or the key value of this bandwidth, the reliability, load, and MTU. See what is key value in HRP. The bandwidth, delay, load, reliability, and MTU. Yeah, you can search for it. So that's why we want to redistribute it and tell to HRP what the metric of RIP. And yeah, in here we have a slide that explain about redistribute. So redistribute have two sides. So first side is a benefit, and second side is a weakness. So subform weakness, I think. So the weaknesses for redistribute is they has hike hike so yeah that is more complex that we know, okay. And there's some change that will make looping from other protocols, and of that not that good, not that good at a big topology. And the benefit is we can make different routing protocols connect to each other, and it will make us easier to um, change routing protocols. Yeah, this is the how to calculate key value, and yeah, so this is the like this. So what we will do to the configuration is register with RIP. Uh, there's a typo here, so register with RIP metrics. 10,000 is the bandwidth, 100 is the delay. Hey, no, 10,000. Wait, oh, load, delay, reliability, delay. Oh, yeah, sure. So 10,000 is the bandwidth, 100 is the delay. Uh, 255 is the reliability, one is the load, and the last one is the MTU. So yeah, you can try it. So first, we'll make the interface loopback. One IP address, yeah, 100, 100 size 30, and after that is router. Sure. Okay, so maybe I will delete network 111 for the router EIGRP 10 known network 111, and after that let's make a dynamic routing RIP protocols, which are RIP version 2 network will make 1, and the last one will make network 100. Now auto summary and okay, so to show to show run, you can see that we have time routing RIP in this router, and after that we will make register. So router EIGRP will make a redistribute configuration in dynamic routing protocol EIGRP as a redistribute RIP matrix 10,000 is for the bandwidth, and the 10 is for 100 is for the uh, was it delay, and after that 255 it will be to reliability, one is load, and the last one will be the MTU, that one well 1500. Enter, and when you see in router C show IP route, you can see that we have IP 111.0 here and 100 100.100 here, and the flag is DX. So the meaning of this flag is D is for EIGRP and X is mean of external. So yeah, this is the IP that coming from an external dynamic routing, or we can say that this come from RIP, right? So yeah, that this is from external routing protocols, and yeah, that's how we redistribute RIP to EIGRP. And okay, maybe that's all that I can show to you guys for this video, and in next video I will show you guys how to redistribute ISPF to EIGRP, and maybe we will make uh, I will use a different topology because we start to uh, learn about failover, load balance, and other material that will need new topology. Okay, so yeah, maybe that's all for me. Thank you for watching, Madam Alvin, and yeah, see you guys in this video. Bye bye.